Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to find the area of a region bounded by the graphs of x to the fourth minus 9x squared and x cubed minus 9x. Okay, please have your calculator ready at this moment and let's get started. At this moment, please have your TI-84 with you because the biggest portion of this problem is to see how the region looks like, and then we're going to pass to the integration and so on. But there's also some algebra steps to figure out where these graphs, the graphs of these two different functions intersect, because one is the fourth order polynomial and the other one is the cubic, and they intersect at certain places, but we want to sort of like figure them out to be able to understand the limits or find out the limits of integration corresponding to different areas, okay? Because we have subregions as well. So please pause the video at this moment and plot these two graphs, x to the fourth minus 9x squared, that's your first function. Second function is x cubed minus 9x. Graph them both, maybe from x min to be -5, x max to be +5 to see the full picture, okay? And I'm assuming that you're pausing the video right now. Please do it. And here we go. I graphed these functions for you. And you should be able to get the same type of graph, okay? So we have the purple graph, that's the cubic, okay? So purple graph is the cubic, so this one is x cubed minus 9x, and the blue graph is the fourth order. As you see, like, these guys are like swirling around, and the areas are sort of like, you have different areas to be covered. So in other words, you have a lot of different subregions here, so we're going to be very careful. So I'm going to split the total region into 3 subregions. So I'm going to call this one A1, I'm going to call this guy A2, and I'm going to call this one A3. So to be able to write down the corresponding integrals representing these areas, I got to know the intersections of these curves, because these subregions are bounded by those vertical lines, like this one, for example, right? And the y-axis, which is something easy to figure out for me. This is like 0, essentially. But for this one, it's not obvious, so that means I need this point. So in other words, I need the intersection point here. I also need this intersection point, okay? So this requires some algebra. So the first thing that I'm going to do, in fact, to set these guys equal and solve for x, okay? So let's do it. I'm going to set x to the fourth minus 9x squared to set equal to x cubed minus 9x, okay? All right, so let's like subtract x cubed minus 9x from both sides of the equation, so that we have a good fourth order polynomial. But also at this moment, I want to rearrange this, these terms, x to the fourth minus x cubed minus 9x squared plus 9x equals 0. Okay, so I need to find the zeros of this equation. I need to know what x solves this fourth order polynomial, and this is an algebra question. But first thing, before even I proceed, is that x is a common factor. I'm going to pull that out. This way, I in fact know one root for sure, that x equals 0. That was the easy root in the graph, right? Easy intersection point, because two graphs intersect at this point here, 0, right? And it's right here, okay? It was sort of like obvious, okay? I need to know other 3 points. So here we have a cubic. And I need to set that to 0 and solve for x, okay? Let me just rewrite that down here. So now the question is like, how do you find the roots of a cubic? If this was a quadratic, we have a quadratic formula, but unfortunately this is not a quadratic, but it's a cubic. So there's no simple recipe to find the roots. The best recipe is trial error by just guessing one of the roots and doing a long division. Okay, so let me just also remind you at this moment what the long division is after we guess the first root, and try simple numbers. For example, x equals 0. Does x equals 0 solve this problem? Solve this equation? Well, probably not, because 0 cubed, 0 squared, and 9 times 0, 0, 0. 9 is not equal to 0. 0 is not a solution, okay? But I can try x equals 1, okay? So 1 cubed, 1 squared, 9 times 1 plus 9 is in fact 0, and x equals 1 is a solution. I found another root. So now, to find the other two roots, I am going for the long division. That means I'm going to divide x cubed minus x squared minus 9x plus 9 by x minus 1. Because x equals 1 solves this problem. That means that x minus 1 is a factor for the cubic. All right, so let's do that. So I'm going to put an x squared here. I'm going to multiply x squared by x minus 1 and subtract it from the cubic. So x cubed minus x squared, right? Subtract all the way. And these terms are gone. So I'm going to carry forward minus 9x plus 9. And that's good, because minus 9x plus 9 is minus 9 times x plus 1. There we go. I'm going to put a minus 9 over there. Okay. And boom. So here, x squared minus 9. So minus 9 times x minus 1. That's exactly minus 9x plus 9. And that, when you subtract, you get a complete 0, which means that x cubed minus x squared minus 9x plus 9 is factored as x minus 1, x squared minus 9. Okay? So now I have to figure out the roots of or factorization of x squared minus 1, but it's not bad because it's the difference of squares. So I'm going to go ahead and then rewrite this quantity. Okay? So x minus 1, and x squared minus 1 is x minus 3, x plus 3. Okay? This is how you get to do factorization of a fourth order polynomial. Okay? All right, so I have x equals 0, x equals 1, x equals 3, and x equals minus 3. So these are the points I was after. So this is negative 3, 0, 1, and 3. Okay, that's the first part of the problem. So now I'm going to evaluate those integrals separately. So I'm going to have a brand new slide for it. Here we go. So I wrote the total area as a sum of A1, A2, and A3. And I'm going to evaluate or construct first. I'm going to construct those integrals by going back to the graph. So here we go. So we need the top and the bottom for each region. Okay. So for A1, the top is the cubic and the bottom is the fourth order. So x cubed minus 9x minus x to the fourth minus 9x squared. So going back up here, x cubed minus 9x, okay, minus x to the fourth minus 9x squared. That's the first part, okay? So now let's look at A2. For A2, top is the blue curve and the bottom is the purple curve, okay? For A2, top is the blue curve, bottom is the purple curve, and purple is cubic and blue is the fourth order. So I'm going to go with fourth order first because that's the top. So So here we go, x to the fourth minus 9x squared minus the cubic. All right, good. And then going back to A3, the top is the purple and the bottom is blue. Okay. Cubic is first and the fourth order next. Okay, here we go. X cubed minus 9x minus x to the fourth minus 9x squared. Okay. All right, so I think we're good to go. I only need the lower and upper limits of the integrals. I'm going to use a different color. For A1, x's are ranging in between -3 and 0, as you see, right? So for A1, it's -3 and 0. For A2, 0 to 1. And for A3, it's 1 to 3. Okay, so let's go ahead and choose -3 here, 0 here, 0, 1, and 1, 3. How about that? Okay. The rest is just evaluating those integrals. Okay. So let's just do one by one. A1 is equal to, I'm going to write down the antiderivative here right away. Okay. So x to the fourth over 4 minus 9x squared over 2 minus x to the fifth divided by 5 and 9x cubed over 3. And this is from -3 and 0, from -3 to 0, okay? And A2, x to the fifth over fifth, 9x cubed over 3 minus x to the fourth over 4, and 9, let's see, 9x squared over 2. Let me just use my space efficiently. 0 and 1. Okay. And I need another slide. All right, I just copied those down here, and I need A3. Okay, x to the fourth divided by 4, 9x squared over 2 minus x to the fifth over 5 minus 9x cubed over 3. It's very similar to A1, but we have different limits, obviously, 1 to 3. Okay? Woohoo! So, go ahead and plug in upper limit and lower limit for each case, and you can pause the video and do your own calculation. But I'm gonna, since this video is already too long, I'm gonna just place the values in, and please double check those. So this is 1053 divided by 20, and 29 divided by 20, and then 68 divided by 5. Okay? Let me just double check everything. Yep, I think we're good. Yeah. All right. So the total area is the sum of these three. And this is, again, I'm just going to put in the result in. You can go ahead and just use your calculator. And in the question is also asking like to approximate it. And let's just do that. 67.7 is the approximation of the total area. Okay. So this was a long question, and it requires a lot of different stuff. Like algebra and integral calculation as well. I think we did pretty good with that. And please check the polynomial division again on your own. And I think that's the end of the video. So I'll see you in another video. Bye.